Good evening, everyone. And we had two wonderful talks before this, exploring both migration and how Postgres works out with ML workloads. But now let's get into some different space altogether. So today I'll be talking about what the role is for Postgres in case of analytics. Like when we are talking about OLAP workloads, where does Postgres actually stand? And what are some ways in which Postgres can actually be a part of that ecosystem? So first, a little bit about myself. I am currently a final year, my name is Akshat Jaimini, and I am currently a final year undergraduate at Thapar University, Patiala. I am completing my 6 months internship as a part of my academic curriculum at Ion Group. It's a fintech com, but leaving that aside, I have been a part of the Postgres community since 2023. I joined through Google Summer of Code 2023, working on the PG Web Testing Harness project, which was mostly related to the official Postgres website. So it is basically an environment where you can test out your various builds that are generated for the official website on a daily basis. After that, in 2024, I moved towards the database observability tools, primarily PG Watch, which is an offering by Cybertech, if I'm correct. Yeah, so there we implemented a feature called RPC sync. So basically you can export all the measurements that you have taken for Postgres, let's say your CPU usage, query performances, etc., and export them to any format that you want. Like it can range from CSV to like just streaming it through Kafka, or you can even send it out to an LLM pipeline, or like there are a lot of possibilities for that, but that was an interesting project. And in 2025, I am trying to get more into the weeds of Postgres, trying to figure out the internals, how the entire system works, and hopefully become one of the hackers by the end of this year. So, in today's talk, we'll first understand what exactly OLAP is. Like, I'm pretty sure everyone is aware of what OLAP is actually, so I don't think I'll be covering that would be of much benefit as such. And we'll also try to understand why Postgres is important in this space. Like, okay, you can say that Postgres is enabled, Postgres can help out with OLAP workloads, but why is it actually required? After this, we'll see what are some existing solutions, what the community has tried to come up with to support this particular use case. Then we'll move on to the crux of this talk, that is talking about the extensions and how they are working. I also have a small demo prepared for this, so we'll see how it provides an practical use case. Yeah, so that's it for the content. So coming to OLAP. So first let's understand what exactly OLAP is. We have heard about many differentiations between databases based on whether it's SQL, NoSQL, document database, vector database. Like there are 1,000 differentiations that you can bring up for each and every database system. But when we talk about the type of workload that database is handling, this is where we have the differentiation for OLTP and OLAP. OLTP is your basic transactional processing databases. So basically your applications that require constant insertions, updations, deletions, right? Whereas in case of OLAP, you are more concerned with the speed at which you are fetching the data and performing some sort of a transformation on it. It can be as simple as a simple sum over a particular column, and then it can range to some sort of an complicated function that provides you with some predictive output, right? And in the middle of this, there lies something called HTAP, which is hybrid transaction analytics processing. This is a very small segment. I think TIDB falls into this category, but yeah, this is also one of the ways in which we can categorize databases based on the type of workloads they are handling. Now, in traditional OLTP systems, whenever we insert any records, let's say in Postgres terms, whenever we insert any tuple, it ends up going inside a page. Now, your page is the actual representation of how your data is being stored on disk. And whenever you execute any query, that page is basically fetched into the memory. Like there's an entire process, but from a high level overview, the page is fetched into the memory, and you basically access your data from that particular segment. In OLTP, you are storing in a single tuple, you are storing all the data for a single record. So let's say column 1 was name, column 2 was age, column 3 was gender, and column 4 was something else related to a person, right? So whenever you store any data, there is a high a particular row will always be stored inside of a single page. But whenever you execute any particular query, let's say this will select star from OLTP-DB, where column 1 has the value of 12. Your query planner will obviously generate an optimized plan, figure out which pages to bring into memory, and then actually pick out that specific record. It can be one or more than one records, and then you can perform whatever operations you want to do. But and similarly, if you want to select a single column, again it will go inside that particular page, fetch it into memory, pick out that single column for you. But when you want to execute a query, let's say select sum on column 1, like you want to sum all the values that are in column 1. In case of OLTP databases, there is a high chance that after some time you might need to jump to a different page. Now there are ways in which we can optimize this by increasing cache, and there are various settings which we can implement. But again, at the architectural level of the storage engine, this is a problem as such, in which the speed of data access decreases drastically. So to resolve that, we were introduced to OLAP systems, which are also called columnar storages, right? And the concept here is that instead of storing an entire row within a single page, you are storing all the data for a single column together. So basically you can have, let's say column 1 was age, right? So you have all the ages stored first, and after that column 2, once those are stored, after the column 2 begins in another page, or after that particular page ends. It depends on what the architecture of the storage engine is, but in summary this is how it should ideally work. So now when we execute the previous sum query, it will run relatively faster because the switching between multiple pages is relatively lower. You have fetched the first page, selected all the records that were there for column 1, and then you switched on to the different page, which increases the performance that you get in these typical read queries. Now there are some caveats that when you're trying to insert data, that particular operation takes relatively more time as compared to OLTP databases. But yeah, this is the trade-off that we have for faster analytics in terms of OLAP databases. Now coming to the actual question, why do we even want to consider Postgres in the OLAP space? Well, of course, as we had seen in the previous talks, Postgres is one of the most used open source databases out there. Now this is an AI overview screenshot that I have attached, but since I am biased for Postgres, I will happily accept this particular figure that over 45,000 companies are using Postgres as of 2025. Personally, from a student's point of view, I have seen Postgres being used at the lowest of levels. Even university students default to Postgres for their college projects or even personal projects. Even universities sometimes tend to use Postgres just for their own projects. And I have done some internships at some startups and some MNCs as well, and there I also saw Postgres in action, which just showcases the scale at which Postgres actually operates. Now, as we heard in the last talk about migrations, moving data from one particular system to another is a huge commitment, right? So now imagine that in case of migrating from an OLTP system like Postgres to an OLAP system like let's say Snowflake, right? So in this particular case, the costs are relatively higher because there is a high chance that you do not have the required expertise concerned to OLAP. Maybe you have the experts for Postgres, but in terms of OLAP, you do not have the required expertise, and it just wastes a lot of time. And last but not the least, Postgres has been there for many decades. Its behavior, its interfaces have been very friendly. So if anyone knows SQL, there is a pretty high chance that they have used Postgres actually, right? So with these points in mind, Postgres becomes really important because you are storing a lot of data on it, and to perform analytics, we might need some better approach. Now moving on to some things that the community has tried before this. So these are some links that you can also check out later on when these presentations are uploaded. But in the first article, this is basically an article from EDB where they are talking about tweaking the shared buffers value, different cache parameters to just improve the processing speed of Postgres over OLAP workloads. And similarly, I do not remember the exact name of this organization, but they had some very interesting interesting statements where they were trying to play around with wall configs, with some replication strategies, again to make Postgres work for OLAP databases, right? Now we even have some patches directly within Postgres. So we have the Coast data type. Like, it sounds really similar to the toast concept that we have in Postgres. So with Coast, you can basically say that, okay, I have this particular column, I want it to be stored in a column as a columnar fashion. That is, in a single page, I want to have all the values that are there for this particular column. Recently, like 2 or 3 days back, when I was working on this presentation, I came across an interesting thread on the hackers list where there was a proposal for introducing vertical columnar indexes directly within Postgres. So this again provides an alternative version of allowing users to store all of their data again in the columnar storage format. And like, there are some hacky ways in which some extensions implement OLAP using JSONB, although I would not recommend using it. But again, like, there have been some hacks that people have been implementing. But the problem with all of these is that we are completely ignoring the fact that Postgres in its essence is an OLTP system. The storage engine is designed in that way, right? We can introduce new patches, we can do a lot of things, as we have seen people have tried to, but it's always better, but when the problem is at the architectural level, it's always better to resort to some different approaches when it comes to using Postgres for OLAP. And this is where we get extensions. So like, this is just a summary of what extensions are for anyone who is not aware of, but like, seeing the recent 2 talks, I think everyone is aware of what extensions are. So it basically allows you to access the have access to the internal workings of Postgres, and introduce new features without specifically forking Postgres and adding your a completely new patch to it. Like, some critical problems that extensions tend to tackle are that you don't need to keep up with all the newer versions of Postgres. With the extensions API, you can just write your extension, and the support for the latest version is sometimes automatically there. Like, if you want to have some specific features related to different versions, you can definitely define some migration scripts for your extension. But yeah, this is a pretty useful way of introducing any new functionalities within Postgres without like touching the existing source code. We also have PGRX, which has recently come into very heavy usage, and you can basically write your Postgres extensions using Rust. And now with extensions, we actually have 2 possibilities that I personally see. So first of all, you can treat Postgres as an analytics generator system. So in this particular use case, you are not modifying how the original let's say architecture of Postgres is. You are just adding some additional items there to facilitate your usage. So some good extensions in this particular area are timescale and ParadeDB. So I'll just go over ParadeDB first, because we have an entire the next some slides are mostly about timescale. But ParadeDB is primarily there for competing with Elasticsearch. They have improved the full text search feature in Postgres using the BM25 algorithm. So they have introduced a new type of index which you can apply on the columns that you want to perform full text search on. They recently had another extension called PG Analytics. So that was really interesting, although they have archived it due to its performance not being as competent as the current OLAP systems. But what they were doing in PG Analytics was they were using data fusion as a query engine. Like, they integrated data fusion within Postgres, and they were using Iceberg to store all of the data that they wanted to. So in this case, Postgres was just acting as a middle layer. You were just using the interactive portions of Postgres, and all of the performance, all of the heavy lifting was being done by data fusion and Iceberg. So yeah, due to performance issues, this was archived. But when we come to timescale, like I hope everyone, most of you, the people here are aware of timescale. So timescale basically deals with providing real-time analytics on time series data, right? So again, they offer both row and column store options by their hypercore technology. So like I found this particular diagram on their official website where they have labeled it hyperstore. But to summarize it, you have all the operations coming within Postgres that has timescale enabled within it, right? These are being stored as your normal in the normal Postgres format as OLTP rows, and after let's say X amount of time, they are automatically migrated to a specific columnar format that timescale has developed, and basically all the real-time analytics is being done on this particular column store. Now there are some concerns that okay, you have two copies of data within the same system, that basically increases the disk usage, etc., but they have come up with some pretty efficient ways to actually compress this particular they have some particular compression algorithms. I think there were some things related to chunking as well. So yeah, timescale is one of the options there, and with all of this you still get all the functionalities of vanilla Postgres that we all use on a daily basis. Another feature that they have is called hypertable, which is basically an enhanced partitioning and query optimization technique, basically an enhanced partitioning scheme for time series data only, right? Now that was like more of a very I would say limited scope of using Postgres in OLAP, but this is where we get to the interesting part and the primary target of this particular talk, that is using Postgres as a platform, right? So when we say that we want to use Postgres as a platform, it means that okay, we are using external tools like Iceberg to store our data in a much more efficient format, but at the same time we are also preserving the core nature of Postgres, and and without having to duplicate data as timescale was doing earlier. So here we have two extensions that deal in this particular space. So we have PeerDB. PeerDB was recently acquired by ClickHouse, and it was basically a tool to facilitate CDC workloads between various other offerings and Postgres. And PGDuckDB has been a recent addition to the extensions ecosystem. So with PGDuckDB, we are actually embedding DuckDB within Postgres. So if you haven't heard of DuckDB, DuckDB is basically similar to SQLite, but for analytics purposes, right? So we are basically embedding DuckDB within Postgres, and with DuckDB we have the capability to directly connect to sources like Iceberg, S3, packet files. You can even connect. I think there is even a functionality to connect with Snowflake clusters as well, right? So it is a part of the MotherDuck ecosystem, which is just a cloud service version of DuckDB, and this extension was primarily developed to ingest data from Postgres into DuckDB, but later on it turned out into something much more. So basically you have your query coming in, you have two engines sitting within your system. First you have Postgres, and then you have DuckDB enabled by the extensions API. So what is happening in this case is based on the nature of the query, the extension decides which particular engine to use. So if you want to deal with Parquet, Iceberg or S3, it directly defaults to DuckDB as the query engine, and when you want to work with your regular data that you have stored in Postgres, it defaults to Postgres. In case DuckDB is not able to, let's say, execute the query, there is also an option to fall back to Postgres again. And like at the core of this extension, we have basically mapped the various types between that are present in DuckDB and Postgres, and we have also mapped the function. So you can directly call the functions that are available in DuckDB through Postgres. Similar to Postgres, DuckDB also supports extensions. So they have extensions for these three formats that we have in the right hand column, and many more. So you can directly utilize those extensions from Postgres as well. Now let's jump on to a quick demo. So if you guys like in this particular demo, we'll be using PGDuckDB along with Iceberg to just see how this particular setup can work in let's say a data lake use case, right? So if you want to try out this with me, you can scan this particular QR code and go and it will lead you to that particular resources for the demo. Okay, so now let's jump into it. Okay, so yeah, so I have this particular container running for me. I'll just yeah. So in this particular container, I have an Iceberg table that stores all of my data. Yeah, so I have this particular Iceberg table. This basically includes data for a delivery platform. So you have tables like the mode of delivery, time take, average time taken, revenue earned, etc., etc. You can actually use DuckDB to okay, this is not working. Yeah, so we can actually utilize Postgres itself to use this. So I have written a script as well for this. Okay, yeah. Yeah, so we can actually go through this entire table using this particular function. So Iceberg scan is actually a function that is present within DuckDB, and all we are doing is giving it a path to our table, and this allowed move paths basically adjust for any path differentiations that are present in the metadata portion of the Iceberg table. So if we just go into it, it will take a couple of minutes in the first second. So yeah, so we have all of these columns. I'm not I don't think everyone is might be able to comprehend all the columns, but yeah, we have shipping date, we have commit date, we have the quantity, extended prices, the date when the item was the receipt for that particular item was generated. Yes, and now we'll see the first use case, that is that we'll directly perform some operations on the Iceberg table from within Postgres. So we'll just turn time and gone, yeah, and let's pick up this particular query. So this is basically to figure out to give you a summary of all the sales that have taken place between these particular dates in the interval of 90 days. Let's pick it up. Okay, and yeah, so we basically have this particular, and it took around 35 milliseconds to get this particular data. Now let's import this data directly into Postgres. I'll just copy the query for ease of use from here. Yeah. Okay, so it basically creates a table within Postgres called data for OLTP, and it just picks out all the entire data from the Iceberg tables and puts it in this particular table. Yeah. So if we do a select star on data for OLTP, we can see we have all the columns that we originally had in that, and now we will take the same query and perform it on this particular database and see how the performance compares to what we were doing on Iceberg. So yeah, it took around 51 milliseconds. In case of Iceberg, it took around 35 milliseconds. When I was testing it earlier, there were some major differences, like with Postgres native tables, we were having around 80 milliseconds to perform the same query, and we can see similar results with some more different queries. Let's pick this up. It took around 7 milliseconds just to perform it on the native Postgres databases, right? And if we pick the same query for to perform it directly on Iceberg, we get okay, yeah, this is surprising. Okay, I executed the wrong query. Oh yeah, just leave that. So basically, we the performance, the basic performance increases mostly because of the format in which the data is being stored on Iceberg. So basically, in this case, when we were executing this particular query, we were utilizing the DuckDB engine to query Iceberg, and when we were executing this particular query, we were actually utilizing just Postgres to query our tables. We also have an option to integrate with MotherDuck Cloud, which is basically a cloud-based version of DuckDB. But the performance on that is a little on the lower side, because there are many factors included, like sending like authentication and sending multiple requests back and forth between the cloud setup and our local system. But yeah, this is still this particular extension is still a work in progress. There are a lot of things that are left to be implemented. Like right now we can read from Iceberg tables, but we lack the ability to write to them, which is something really important if you want to actually put it in a production environment for a data lake use case. But yeah, there have been some initiatives that are trying to make Postgres a viable candidate for OLAP workloads. And similar to PG-DuckDB, we also have PG Mooncake, which combines PG-DuckDB along with TimescaleDB to provide some more enhanced real-time analytics. I was actually trying to create a similar mock-up for this particular presentation, but there are some compatibility issues when you try to work with hypertables and timescale and try to query them with using the DuckDB engine. But yeah, there is a lot of work to be done on this. We have seen so there are already some major performance differences between what this extension is enabling Postgres to do. And yeah, so with this we would like to conclude this presentation, and we are open for Q&A.
So did you perform any POC, like how much optimization?
Yeah, so basically the particular page for this extension has all of those benchmarks. And testing is still being done on this particular extension, because there is as I said, there is a lot of work that has been left for this particular use case. But yeah, with the initial local tests that are conducted, there were some major performance differences between how this particular thing operates.
OLTP system that you have mentioned, which you are executing using the DuckDB.
Yeah.
Can you create the index on top of that system?
For OLTP systems, yeah. So when we are creating indexes, like it's just the indexes that Postgres will create on it. DuckDB won't have a role to play in that. Like OLTP will specifically be handled by Postgres, and we have delegated all the OLAP work to DuckDB in this case.
So can't we create index on OLTP workload and try the same testing? I think it provide the same kind of performance.
Yeah, that is a valid use case. Like that is a valid question actually. So that is the particular thing that the developers are trying to figure out right now, how to improve more performance for this extension. Yeah. Okay. So thank you.
Thank you.